Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to be talking about average rate of change and different terms connected to that. So let's go ahead and get started. So here's a graph, and there's a lot of interesting things here that are happening. Now, when we're talking about the average rate of change, we're talking about change over time. In other words, it's not consistent, but what's happening is that if you take what's kind of happening over a certain period of time, as I've already mentioned, you can get an idea of the average of what's going on. And before we get into the details of that, the first thing we have to talk about is you can see this graph right here. The orange represents a parabola, x to the third minus 4x. And then we have these different things here, minus 1, or m equals minus 1, m equals 8, m equals 8. And these things right here, these different m's, of course, I'm assuming you know that m stands for slope. These in this particular situation are called, what we like to call them tangents. And a tangent is something that touches a curve at one point and only one point and kind of slides up against it. So if you look at, again, if you look at this example right here, you can see that this guy, he touches it right here at 2 and kind of keeps on going like that. And so this is m equal 8. And then over here we have the same one at negative, when x is negative 2, the slope here is also 8. So it kind of glides up here along that little curve at that particular slope. And then we also have this minus 1 here where it starts at x equals minus 1, goes up, touches right at 3, and kind of goes downward. And so how you determine the slope here in this particular, the tangent is what direction is the actual function going in, and then you kind of line up your tangent accordingly. So again, going back to this example right here, you can see that at 2 it's going up. It's going up right here, and so thus this is why the tangent is kind of following this line right here. But when we get over here, you can see when it's at negative 1, it's kind of going down because it's following this downward curve like so. So that's why it's pointing downward. And so these are tangents. And so this is kind of the first step in trying to understand rate of change, because we can find right here that at this particular moment, the rate of change is 8, the slope. Negative 1. I'm using this, I'm using this guy right here. And then for when x is negative 2, the rate of change is 8. And when the rate of change here is positive 2 is 8. And we get that because the line is going up. Since it's increasing, the rate of change is positive. But when we're at x equals negative 1, you can see here clearly that the line is going down. This is why the rate of change is negative 1. That's what's happening there. Or I'm not the rate of change, the instantaneous change is probably what I meant to say there. Now, moving from there, there's something else that we need to look at, and that is something called a secant. Now, when you have a secant, what's happening here is that you can see the difference this time is that now our line is going through 2 points on the graph. 2 points. And so the distance here, right here in between these, we can use this to calculate the average rate of change from point A to point A plus H. That's what's happening. And this is setting the foundation for trying to understand what derivatives are. This trying to understand the rate of change over time. You start with tangents, which is kind of like an instantaneous point, if you will. And now we're moving to change over time, if you will. So now that we have this background information, we're going to try to deal with how to do this. So we're going to kind of have a graph. This is not going to be a perfect representation, but you'll get the idea in a second, where we have this graph here. So I have a graph over here in the corner. I'm not going to draw it too big. And so let's just say I have some crazy curved line here. Go back here, use a different color. And it's kind of something, wild like this, something like that. And so now I'm going to draw my secant. And my secant is going to be kind of something as follows. Just make that another color. All right, how about that one? Something like this. This is not perfect, but you get the idea. And so the points that we're going to be using here are as follows. But before I give you the points, I want to give you the formula for the average rate of change. I need to do that first. Whoa. For the sake of clarity. Okay, let me redo that. So I'm going to change the color back. I made a mistake there. It's okay. All right. Now, let's talk about the actual formula. So the formula to find the average rate of change is as follows. It's going to be f of a plus h minus f of a over h. H represents the displacement. Now, for our purposes, this is what we're going to have here. We're going to have the following points. So our points are going to be 2 minus 6. So that would probably be this guy up here. 2 minus 6. And then we're going to have the second points of negative 1, 5. Like so. So negative 1, 5 would probably be something like way over here. But you can see this is not drawn to scale. We'll just say about right here. Again, it's not perfect. We're not trying to be perfect here. Now, here is what we do. So let's go ahead and go to the next slide. We are going to do as follows. We're going to plug in all this information. So what's going to happen is that I'm just going to draw my points again so that we have them for a reference. And then we're going to have our negative 1 and then our 5 here. Now, what's happening here is that the a in our actual equation from the previous slide, our a here is going to be the 2. So 2 is going to equal a. That is the first thing we have to understand. So this is our a. A equals 2. We know that. And so if you want to try to understand what's happening here, this is how it works. So you have 2. And then we need to figure out, well, what is f of 2? And for our purposes, we know what that is. F of 2 is going to equal negative 6. That's what's going on here because this is our a. And so when we have 2, we get out the negative 6. We're just going through everything step by step incrementally. Now, we need to try to calculate something called the displacement. And the displacement is going to represent our h in the previous slide. So right here, this is our h, the denominator. And that is going to be as follows. We're going to take our first y value, our first x value and the second one. So we're going to put a minus 1. And we're going to subtract 2 because this is our first x value in the first point, our first set of points. And so when we do that, we get negative 3. So we're pulling things together piece by piece, step by step, if you will, as we go through this. Now, let's continue, shall we? I ran out of space again. All right, so this is what's going to happen now. We are going to have the following information. We know that our h, just so you know, our h is minus 3. I hope you haven't forgotten that. And our f of 2, we already calculated that. It's basically our y value for the first set of points is negative 6. Now we're going to calculate f of a plus h. So we know that a is going to be 2 plus our h here that we just calculated is negative 3. And that is going to give us negative 1. So that is our f of a plus h. And that should look familiar because if you go back to our original point here, you can see that that's basically our x value right here. Same thing, not that deep. Now, so we know f of a plus h is negative 1. So going with that same thought, f of negative 1 is going to equal 5 because remember, that is what we have right here. Our y value, so when f is negative 1, our y value is 5. That should be obvious by now. And so when we finally plug everything in, we get the following. We get 5 minus negative 6, all this over negative 3. And so negative 3 is our displacement, our h value. This 5 here is our a plus h, or you could just say it's like the second y value in our second set of points there. And then this negative 6 is our first y value. That's all it is. So this is kind of a roundabout way of calculating the slope. And so when you go through this entire process, you get, well, 5 minus minus 6 is going to be positive 11. And then we still have that negative 3 on the bottom. And this is our answer. So the average rate of change, when we are looking at the values of 2 minus 6 to our 2 negative 6 and negative 1, 5, that average distance is going to be negative 11 over 3. In other words, it's decreasing. That's what's happening. It's going in a negative direction. It's going down. It's losing value. That is what's happening. And this is how you address dealing with finding the average rate of change. And so again, like I said, it's just a roundabout way of calculating the slope. But we need to make sure that we understand all these because we're not stopping here. We're laying the foundation for understanding derivatives and average rate of change or change over time, and where you could do all kind of very complex calculations and things of that nature. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for watching. Take care.